Milky Way versus Andromeda, the cosmic collision that may never happen. A documentary script by Night Tales Docs. For decades, we have lived with a terrifyingly beautiful certainty, a prophecy written in the stars themselves. In approximately 4.5 billion years, our Milky Way galaxy, our cosmic home, the swirling island of 100 billion stars that cradles everything we have ever known, would be torn apart. It would collide head-on with our nearest galactic neighbor, the great Andromeda galaxy. Two titans of the local group, locked in a gravitational death spiral from which there would be no escape. The result? A new galaxy, a new cosmic order. And our sun? Tossed into a completely different orbit, perhaps even ejected into the cold, empty void of intergalactic space. It was as certain as death and taxes, as the old saying goes. A cosmic inevitability. But what if I told you that everything has changed? That in 2025, a bombshell study turned this cosmic certainty on its head. What if the Milky Way and Andromeda might never collide at all? What if the fate of our galaxy is not written, but is, instead, a cosmic coin toss? Welcome to Night Tales Docs. Tonight, we journey 10 billion years into the future to explore the greatest collision that never was. This is the story of the Milky Way versus Andromeda, and the truth is far stranger than we ever imagined. For decades, we have lived with a terrifyingly beautiful certainty, a prophecy written in the stars themselves. In approximately 4.5 billion years, our Milky Way galaxy, our cosmic home, the swirling island of 100 billion stars that cradles everything we have ever known, would be torn apart. It would collide head-on with our nearest galactic neighbor, the great Andromeda galaxy. Two titans of the local group, locked in a gravitational death spiral from which there would be no escape. The result? A new galaxy, a new cosmic order. And our sun? Tossed into a completely different orbit, perhaps even ejected into the cold, empty void of intergalactic space. It was as certain as death and taxes, as the old saying goes. A cosmic inevitability. But what if I told you that everything has changed? That in 2025, a bombshell study turned this cosmic certainty on its head. What if the Milky Way and Andromeda might never collide at all? What if the fate of our galaxy is not written, but is, instead, a cosmic coin toss? Welcome to Night Tales Docs. Tonight, we journey 10 billion years into the future to explore the greatest collision that never was. This is the story of the Milky Way versus Andromeda, and the truth is far stranger than we ever imagined. It all began in 1912, a time when our understanding of the universe was still in its infancy. Astronomers at the time looked through their telescopes and saw something peculiar in the night sky. A faint, fuzzy patch of light, what they called a spiral nebula, was behaving strangely. It was moving toward us. The Andromeda galaxy, then thought to be just a cloud of gas and dust within our own Milky Way, was actually hurtling through space at nearly 250,000 miles per hour, directly toward our galactic home. At the time, nobody fully understood what this meant, but the seed was planted. Something was coming. A century later, in 2012, astronomers using NASA's Hubble Space Telescope made a landmark discovery. They measured the sideways motion of Andromeda, its transverse velocity, and found it was so negligible that an eventual head-on collision with the Milky Way seemed almost certain. The two galaxies were on a crash course. There was no escape, no deviation, just an inexorable march toward a cosmic collision. It was, in the words of Benjamin Franklin, as certain as death and taxes. To understand the magnitude of this event, we must first understand the players involved. The Milky Way is a barred spiral galaxy, a majestic disk of stars, gas, and dust stretching 100,000 light-years across. It contains between 100 and 400 billion stars. Our Sun, along with our entire solar system, orbits about 26,000 light-years from the galactic center, a quiet neighborhood in one of the galaxy's spiral arms. Andromeda, also known as Messier 31, is even larger. It spans approximately 220,000 light-years and contains more than 1 trillion stars. It is the most massive galaxy in the local group, the small cluster of galaxies that includes our own. Andromeda is the only major galaxy in the universe that is speeding toward us. Every other galaxy is rushing away. The universe itself is expanding, pushing galaxies apart. But not Andromeda. It is locked in a gravitational embrace with the Milky Way, falling toward us at roughly 110 kilometers per second. At that speed, in the time it takes you to read this sentence, the distance between our galaxies will have shrunk by nearly 800 miles. The collision, when it came, would be devastating. A smash-up between our galaxy and Andromeda would trigger a firestorm of starbirth, supernovae, and the complete destruction of both spiral structures. The beautiful pinwheels we know today would be gone forever, replaced by a massive, featureless elliptical galaxy that scientists had already nicknamed Milky. The gravitational forces would tear both galaxies apart. Long tidal tails of stars and gas would be pulled out into intergalactic space. The cores would eventually merge, compressing interstellar gas clouds and triggering an immense starburst, the birth of billions of new stars. And our solar system? There was a 50% chance it would be pushed 3 times farther from the galactic core, and a 12% chance it would be ejected entirely, hurled into the cold, dark void of intergalactic space. This was the future we believed was certain, until now. Fast forward to June 2025. A team of international astronomers from the University of Helsinki, Durham University, and the University of Toulouse published a study that would change everything. Using over a decade's worth of data from NASA's Hubble Space Telescope and the European Space Agency's Gaia Space Telescope, they re-examined the long-held prediction. And what they found shocked the scientific community. There is only a 50-50 chance that the Milky Way and Andromeda will collide within the next 10 billion years. 50%, a cosmic coin toss. The team ran an astonishing 100,000 computer simulations of the 2 galaxies' future trajectories. They included something previous studies had not: the gravitational influence of other nearby galaxies, particularly the Large Magellanic Cloud, a small satellite galaxy orbiting the Milky Way. And here's where it gets truly fascinating. The Large Magellanic Cloud, though only about 15% of the Milky Way's mass, exerts a gravitational pull that is perpendicular to the orbit between the Milky Way and Andromeda. This tug, this tiny gravitational nudge, is enough to significantly perturb the Milky Way's motion. It can change our galaxy's trajectory just enough to make a collision with Andromeda far less likely. While some earlier works had focused on the interaction between the Milky Way, Andromeda, and the Triangulum galaxy, we also include the effect of the LMC, explained Dr. Till Sawala, lead author of the study. Although its mass is only around 15% of the Milky Way's, its gravitational pull, directed perpendicular to the orbit with Andromeda, perturbs the Milky Way's motion enough to significantly reduce the chance of a merger with the Andromeda galaxy. The new findings represent a dramatic shift from the previous consensus. Under the old model, a collision was virtually certain within 4 to 5 billion years. The new study found only a 2% probability that the galaxies will collide in the next 5 billion years. In just over half of the simulated scenarios, the the Milky Way and Andromeda experience at least one close encounter before losing enough orbital energy to eventually collide and merge. But that would happen in 8 to 10 billion years, not 5. And in most other cases, the two galaxies pass at such a large distance that they continue to evolve largely unperturbed for a very long time. The fate of our galaxy is no longer certain. It is, in the words of the researchers, completely open. Even using the latest and most precise observational data available, the future of the local group of several dozen galaxies is uncertain. Intriguingly, we find an almost equal probability for the widely publicized merger scenario, or, conversely, an alternative one where the Milky Way and Andromeda survive unscathed. So what would actually happen if the collision does occur? Let us walk through the timeline, step by step, as revealed by the most advanced computer simulations available. Today, the Milky Way and Andromeda are separated by approximately 2.5 million light-years. They are approaching each other at about 110 kilometers per second. Long before any potential collision with Andromeda, the Milky Way is almost certain to collide with the Large Magellanic Cloud. This small satellite galaxy, which is already being torn apart by our galaxy's gravity, will merge with the Milky Way in about 2 billion years. This event alone will reshape our galaxy, triggering new star formation and altering its structure. If the collision with Andromeda is going to happen, this is when it begins. At approximately 3.75 billion years from now, Andromeda and the Milky Way prepare for their initial close pass. The two galaxies will not collide head-on. Instead, they will interpenetrate, passing through each other in a cosmic dance. The immense tidal forces will warp both galactic disks, pulling out long, spectacular tidal tails of stars and gas into intergalactic space. The night sky from a future Earth, if anyone were still there to see it, would be a breathtaking sight. The distorted disk of Andromeda would dominate the view, appearing far larger and brighter than anything we see today. As the galaxies begin to interact, the sky brightens from the emergence of newly formed stars. The gravitational compression triggers the first wave of star formation, lighting up the merging galaxies with brilliant blue light. Tidal forces warp the Milky Way's disk and stretch Andromeda into long tails of stars. The beautiful spiral structures that define both galaxies begin to distort beyond recognition. After the first pass, the galaxies separate, slowed by their mutual gravity. But they cannot escape each other entirely. They slow down, stop, and begin to fall back toward one another. The subsequent separation is briefer because their gravity prevents them from straying too far apart. At approximately 6 billion years from now, the cores of the Milky Way and Andromeda finally merge. This is the moment of ultimate destruction and creation. The merger of the two galactic cores causes a massive compression of the interstellar gas clouds from both galaxies, triggering an immense starburst. The rate of star formation increases dramatically, and the newly formed galactic center shines with the light of billions of new, hot, blue stars. Over the next several billion years, the chaotic motions subside. The tidal tails fall back and are absorbed, and the stars from both galaxies settle into new, randomized orbits. The beautiful spiral structures of the parent galaxies are completely erased. By 10 billion years from now, the merger is complete. What remains is a single, massive, and relatively featureless elliptical galaxy, Milkomeda, a giant containing more than 1 trillion stars. The Milky Way and Andromeda, as we know them, are gone. Their legacy is a new cosmic entity born from destruction. But remember, there is a 50% chance this never happens. In the alternative scenario, the Milky Way and Andromeda make their close approach, but at such a large distance that they avoid a collision entirely. In these simulations, the two galaxies pass each other, their gravitational fields briefly distorting each other's shapes, but they continue on their separate paths. They may approach again in the distant future, or they may drift apart forever. The Large Magellanic Cloud in this scenario has done its job. Its perpendicular gravitational pull has nudged the Milky Way just enough to avoid the cosmic catastrophe that once seemed inevitable. Both galaxies survive. Both remain intact. The Milky Way continues to orbit the center of the local group, and Andromeda continues on its own trajectory. The two titans pass each other in the cosmic night, close but never touching. It used to appear destined to merge with Andromeda, forming a colossal Milkomeda, said Professor Alice Deason of Durham University. Now, there is a chance that we could avoid this fate entirely. All of this raises an obvious question. What happens to Earth? What happens to our solar system? The short answer, surprisingly, is that even in the collision scenario, our solar system would likely survive. Galaxies are mostly empty space. As one astronomer put it, if the Sun were a ping-pong ball, then Proxima Centauri, the closest star to the Sun, would be a pea about 680 miles away. Despite containing more than 1 trillion stars combined, the galaxies are so diffuse that actual star-on-star collisions are incredibly unlikely. None of the 1.3 trillion stars are expected to collide during the Andromeda-Milky Way collision. The solar system will in all likelihood be almost unaffected, said one astronomer. A galactic collision won't violently throw planets and stars around like billiard balls, but it will change things, some visibly. The part of the solar system that would most likely be affected by the Milky Way-Andromeda collision would be the Oort cloud, a distant region of icy objects and comets surrounding the outer edges of the solar system. Gravitational disruptions could send comets careening into the inner solar system, but the planets themselves would likely remain intact. However, our location in the galaxy would change dramatically. Modeling suggests a 50% probability of the solar system being displaced 3 times its current distance from the galactic core, and a 12% chance of ejection into intergalactic space. If the collision occurs, we would end up at the very outer edge of the new Milkomeda galaxy, a lonely outpost in a new cosmic neighborhood. But here is the cruel irony of this entire story. By the time any of this happens, whether in 4 billion years or 10 billion years, Earth will already be uninhabitable. In about 1 billion years, the Sun's increasing luminosity will make our planet too hot for liquid water to exist. Long before the galaxies collide, our oceans will have boiled away. Life on Earth, as we know it, will be a distant memory. The collision of galaxies, whether it happens or not, is a footnote in Earth's story. Our planet's fate was sealed by our own star long before Andromeda ever got close. Even though life on Earth would have ended by then due to the Sun's increasing heat, this cosmic event would offer a stunning view of the changing night sky, if anyone was still there to see it. So why did we get it wrong? How did a cosmic certainty become a cosmic coin toss? The answer lies in the nature of science itself. In 2012, when Hubble astronomers measured Andromeda's motion and found it was on a collision course, they were working with the best data available at the time. But that data had limitations. The transverse velocity of Andromeda, its sideways motion, was incredibly difficult to measure precisely. Over the following decade, Hubble continued to observe Andromeda, and the European Space Agency's Gaia Space Telescope, launched in 2013, began providing unprecedented precision in measuring the motions of stars throughout the Milky Way and beyond. With this new data, scientists could run far more sophisticated simulations. They could include more variables. They could account for uncertainties that previous studies had to ignore. When we tried to start from the same assumptions as previous researchers, we recovered the same results. Dr. Sawala explained. We've simply been able to explore a much larger space of possibilities, taking advantage of new data. They ran 100,000 simulations, each with slightly different initial conditions to account for the uncertainties in our measurements. In some, the galaxies collided. In others, they did not. And in half of them, the result was a near miss. The collision had seemed much more likely in 2012, when the measurements were less precise. It's somewhat ironic that, despite the addition of more precise Hubble data taken in recent years, we are now less certain about the outcome of a potential collision. That's because of the more complex analysis and because we consider a more complete system. The story is not over. The uncertainty will not last forever. The team is already looking ahead to researching further scenarios when even more data become available. The Gaia Space Telescope will soon deliver more precise measurements of some of the most crucial variables, including the transverse motion of Andromeda. The only way to get to a new prediction about the eventual fate of the Milky Way will be with even better data, said Dr. Sawala. The universe is a dynamic place, constantly evolving. We see external galaxies often colliding and merging with other galaxies, sometimes producing the equivalent of cosmic fireworks when gas, driven to the center, ignites. Our own local group is no exception. The fate of the Milky Way and Andromeda will ultimately be determined by forces we are still working to understand. Dark matter, the distribution of mass in the local group, the gravitational influences of every satellite galaxy, large and small. And so, we arrive at the end of our journey, 10 billion years into the future, a future that is now, paradoxically, more uncertain than ever. For a century, we believed we knew the fate of our galaxy. We told ourselves a story of cosmic inevitability, of two titans locked in a gravitational death spiral. We imagined the destruction of our galactic home, the birth of a new galaxy, the possible ejection of our solar system into the void. But the universe, it turns out, had other plans. The latest science tells us that our cosmic destiny is not written. It is a coin toss, a 50-50 chance. And whether the Milky Way and Andromeda collide or pass each other by depends on forces so delicate, so subtle, that we are only now beginning to measure them. In a way, this is a more beautiful story than the one we told before. The universe is not a deterministic machine, grinding inevitably toward a preordained conclusion. It is a dynamic, living thing, full of uncertainty and possibility. The fate of our galaxy is not sealed. It is still being written, and we, here on this tiny blue planet, are the ones writing it. Every measurement we make, every observation we conduct, every simulation we run, it all brings us closer to understanding our place in the cosmos. We won't be around to see the outcome. The sun will have expanded and consumed our planet long before the galaxies make their final approach. But that doesn't make the question any less meaningful, because the question of our galaxy's fate is really a question about who we are and where we came from. It is a question about the nature of the universe itself. Whether Milkomeda is born or the galaxies drift apart, the story of the Milky Way versus Andromeda is a reminder of something profound. We are part of something vast and ancient and beautiful. We are stardust, contemplating the fate of stars. We are fleeting, yet we reach for eternity. And in that reaching, in that searching, we find meaning. We ended our last journey with a question mark hanging over the cosmos. The certainty of a galactic collision, the prophecy we had held for over a century, had been reduced to a coin toss, a 50-50 chance. The fate of our Milky Way, it seemed, was no longer written in stone. But that was only the beginning of the story. Because when you pull on one thread of the cosmic tapestry, the entire picture begins to shift. And what we discovered next would challenge not just our understanding of the future, but our understanding of the past as well. Welcome back to Night Tales Docs. This is part 2 of our journey into the heart of the Milky Way versus Andromeda story. And trust me when I say this, the deeper we go, the stranger it gets. Let us begin with the elephant in the room, or rather, the dwarf galaxy in the room. The Large Magellanic Cloud. For decades, this small satellite galaxy orbiting our Milky Way was treated as little more than a footnote in the cosmic story, a minor player, a bit player in the grand drama of galactic evolution. But the 2025 study changed all of that. You see, the Large Magellanic Cloud, despite being only about 15% of the Milky Way's mass, exerts a gravitational pull that is directed perpendicular to the orbit between the Milky Way and Andromeda. And this perpendicular tug, this tiny gravitational nudge, is enough to significantly perturb the Milky Way's motion. It can change our galaxy's trajectory just enough to make a collision with Andromeda far less likely. Andromeda. Think of it this way. Imagine you are walking down a long corridor, heading straight for a door at the end. You are certain you are going to walk through that door. It is inevitable. But then, someone reaches out and gives you the slightest push from the side. Just a gentle nudge. You stumble slightly, adjust your course, and suddenly you miss the door entirely. You brush past it, close but never touching. That is what the Large Magellanic Cloud is doing to our galaxy. It is that gentle nudge, that cosmic stumble, that could save the Milky Way from its seemingly inevitable fate. But here is where it gets even more fascinating. The Large Magellanic Cloud is not just some passive observer in this cosmic drama. It is on a collision course with the Milky Way itself. In about 2 billion years, the Large Magellanic Cloud will merge with our galaxy. This event alone will reshape the Milky Way, triggering new star formation and altering its structure long before Andromeda ever gets close. So the very galaxy that might save us from a collision with Andromeda is itself destined to be consumed by us. It is a cosmic irony of the highest order, the savior and the sacrifice, all in one. Now, let us talk about those 100,000 simulations. Because the scale of what the research team accomplished is almost impossible to comprehend. Led by astrophysicist Till Sawala of the University of Helsinki, the team set out to do something that had never been done before. They took over a decade's worth of data from NASA's Hubble Space Telescope and the European Space Agency's Gaia Space Telescope. And they used that data to run not one simulation, not 10, not even 1,000. They ran 100,000 simulations of the future trajectories of the Milky Way and Andromeda. 100,000 different possible futures. In each simulation, they slightly varied the initial conditions to account for the uncertainties in our measurements. The mass of the galaxies, their exact positions, their exact velocities, the gravitational influence of every nearby galaxy, large and small. And what did they find? In half of those simulations, the galaxies collided and merged. In the other half, they passed each other by and continued on their separate paths. A perfect 50-50 split. A coin flip is the more accurate description, Sawala told National Geographic. And he was not being dramatic. That is literally what the numbers showed. A cosmic coin toss. But here is the part that really surprised the scientific community. Even in the simulations where the galaxies did eventually merge, it did not happen in 4 to 5 billion years, as previously believed. In most of those simulations, the merger did not occur until 8 to 10 billion years from now, twice as long as earlier estimates. The study found only a 2% probability that the galaxies will collide in the next 5 billion years. 2%. That is not just a reduction, that is a complete reversal of everything we thought we knew. Proclamations of the impending demise of our galaxy seem greatly exaggerated, the team wrote in their paper, published in the journal Nature Astronomy. And that brings us to a crucial question. How did we get it so wrong? How did a cosmic certainty become a cosmic coin toss? The answer, as with so much in science, lies in the data, or more precisely, in the lack of it. In 2012, when astronomers Roland van der Merel and Tony Son published their landmark analysis of Hubble observations, they were working with the best data available at the time. They measured the sideways motion of Andromeda, its transverse velocity, and found it was so negligible that an eventual head-on collision seemed almost certain. But those measurements had limitations. The transverse velocity of Andromeda is incredibly difficult to measure precisely. We are talking about a galaxy 2.5 million light-years away, moving at hundreds of thousands of miles per hour. Measuring its sideways motion with enough precision to predict its trajectory billions of years into the future is like trying to predict the path of a bullet by looking at it from across the ocean. Over the following decade, Hubble continued to observe Andromeda, and then, in 2013, the European Space Agency launched the Gaia Space Telescope. Gaia began providing unprecedented precision in measuring the motions of stars throughout the Milky Way and beyond. It mapped the positions and movements of over 1 billion stars with astonishing accuracy. With this new data, scientists could run far more sophisticated simulations. They could include more variables. They could account for uncertainties that previous studies had to ignore. We have the most comprehensive study of this problem today that actually folds in all the observational uncertainties, Sawala explained. It's somewhat ironic that, despite the addition of more precise Hubble data taken in recent years, we are now less certain about the outcome of a potential collision, he continued. That's because of the more complex analysis and because we consider a more complete system. In other words, the more we learn, the less certain we become. And that is not a failure of science. That is science working exactly as it should. Science is not about certainty. It is about reducing uncertainty. And sometimes that means discovering that what you thought was certain was actually anything but. Now, let us step back for a moment and consider the broader context. Because the Milky Way and Andromeda are not the only players in this cosmic drama. They are part of a larger structure called the Local Group, a collection of more than 50 galaxies bound together by gravity. The third largest galaxy in the Local Group is the Triangulum Galaxy, also known as Messier 33. And the Triangulum Galaxy is also gravitationally interacting with both the Milky Way and Andromeda. In some of the simulations, Triangulum joins the dance, adding another layer of complexity to an already chaotic system. The Milky Way and Andromeda alone would remain in the same plane as they orbit each other. But this doesn't mean they need to crash, the researchers noted. The future of the Local Group, with its several dozen galaxies, is uncertain. Intriguingly, we find an almost equal probability for the widely publicized merger scenario, or, conversely, an alternative one where the Milky Way and Andromeda survive unscathed, Sawala said. And that brings us to perhaps the most profound implication of this new research. If the Milky Way and Andromeda do not merge, what happens to the concept of Milkomeda, the name that scientists had already given to the future merged galaxy? For years, textbooks, documentaries, and scientific papers had described the eventual formation of Milkomeda as a certainty. It was a staple of popular science. The beautiful, haunting image of two spiral galaxies colliding and merging into a single, featureless elliptical galaxy. It was poetic, it was dramatic, and it was, apparently, not guaranteed. If the galaxies avoid collision, there will be no Milkomeda. The Milky Way will continue as the Milky Way. Andromeda will continue as Andromeda. Two separate galaxies, orbiting each other in a slow cosmic dance, never quite touching. But let us not get ahead of ourselves, because even if the collision does not happen, the story is far from over. The universe is a dynamic place, constantly evolving, and there are other forces at work that could reshape our galaxy in ways we are only beginning to understand. Take dark matter, for example. Dark matter is the invisible substance that makes up about 85% of the matter in the universe. We cannot see it, we cannot detect it directly, but we know it is there because of its gravitational effects on visible matter. Dark matter plays a crucial role in the dynamics of galaxies. It forms enormous halos around galaxies, extending far beyond the visible disks of stars and gas. And when two galaxies interact, it is their dark matter halos that interact first, long before any stars get close. The dark matter halos of the Milky Way and Andromeda are already interacting. They are already feeling each other's gravitational pull. And this interaction, this cosmic dance of invisible matter, will ultimately determine the fate of both galaxies. But here is the thing. We do not fully understand dark matter. We do not know exactly how it is distributed. We do not know exactly how it behaves. And that uncertainty feeds directly into the uncertainty of our simulations. The only way to get to a new prediction about the eventual fate of the Milky Way will be with even better data, Sawala said. And that is exactly what the scientific community is working toward. The Gaia Space Telescope will soon deliver even more precise measurements of some of the most crucial variables, including the transverse motion of Andromeda. Future space telescopes, like the Nancy Grace Roman Space Telescope and the Euclid mission, will provide even more data on the distribution of dark matter and the dynamics of galaxies. The story is not over. The uncertainty will not last forever. With each new observation, each new measurement, we get a little closer to understanding the true fate of our galaxy. Now, let us talk about the human element of this story. Because for all the talk of galaxies and dark matter and computer simulations, there is something deeply personal about this cosmic drama. We are, after all, inhabitants of the Milky Way. This is our home. Every star we have ever seen, every planet we have ever discovered, every hope and dream and memory of every human being who has ever lived, it all exists within this one galaxy. The idea that our galaxy could be destroyed, torn apart, and absorbed into something else, it touches something primal in us. It speaks to our fear of impermanence, our fear of endings. And that is why the new findings have resonated so deeply with the public. Because they offer a kind of hope, a possibility that our cosmic home might survive, that the Milky Way might continue, intact and beautiful, for billions of years to come. As one researcher put it, the possibility of a galactic near miss is somehow comforting. It is nice to think the Milky Way still has a long, planet-forming future ahead of it. But let us be honest with ourselves. Even if the Milky Way survives, even if it never collides with Andromeda, our planet will not be around to see it. In about 1 billion years, the sun's increasing luminosity will make Earth too hot for liquid water to exist. The oceans will boil away. The atmosphere will be stripped. Life on Earth, as we know it, will be a distant memory. Long before the galaxies make their final approach, whether in 5 billion years or 10 billion years, our planet will be a barren, lifeless rock. The collision of galaxies, whether it happens or not, is a footnote in Earth's story. Our planet's fate was sealed by our own star long before Andromeda ever got close. But that does not make the question any less meaningful, because the question of our galaxy's fate is really a question about who we are and where we came from. It is a question about the nature of the universe itself. And there is another angle to this story that we have not yet explored. Because while we have been focused on the future of the Milky Way and Andromeda, scientists have also been looking at the past. And what they have found is truly remarkable. In 2026, a team of researchers led by Paris Observatory astronomer Francois Hammer published a study that revealed something astonishing about Andromeda itself. Andromeda, it turns out, was formed in a colossal crash between two smaller star systems. And this crash happened no more than 3 billion years ago, when Earth already existed. Let that sink in for a moment. 3 billion years ago, when life on Earth was already well established, two galaxies collided and merged to form the Andromeda we see today. The data showed that between 7 and 10 billion years ago, two galaxies, one 4 times more massive than the other, found themselves on a collision course. The team simulated both precursor galaxies' trajectories and calculated that they fused between 1.8 billion and 3 billion years ago to forge Andromeda. This is a profound revelation. It means that Andromeda, the great galaxy that has been bearing down on us for so long, is itself the product of a galactic collision. It is a merger survivor. It has been through this before. And that changes everything about how we think about a potential Milky Way-Andromeda collision. Because if Andromeda has already survived one major merger, it is a battle-hardened veteran of galactic collisions. It knows how to merge. It has done it before. But there is another implication here that is equally fascinating. The fact that Andromeda was formed from a merger just 3 billion years ago explains some of the peculiarities we see in the galaxy today. Previous research had noted one major difference between our own galaxy and Andromeda, long considered twin clusters. In Andromeda, certain stars orbit erratically, while in the Milky Way, all stars observe a simple rotation around the galaxy's center. Why? Because Andromeda is still recovering from its recent merger. The star agitation we see in Andromeda is the aftermath of that ancient collision. Andromeda is still settling down from a crash that happened billions of years ago. Imagine that. A galaxy so vast, so massive, that it takes billions of years to recover from a collision. And now, here it comes, hurtling toward us, perhaps to do it all over again. The cosmic drama is not just about the future. It is about the past, too. Andromeda's past is written in its stars, in the chaotic orbits of its outer regions, in the tidal tails and streams of debris that still bear witness to that ancient merger. And if Andromeda and the Milky Way do eventually collide, future astronomers, if there are any, will see similar signs in the merged galaxy. They will look back at the chaotic motions of stars and say, this galaxy was formed from a merger. Two great spirals came together and became one. But here is the thing. If the Milky Way and Andromeda do collide, they will not just merge into a single galaxy. They will also trigger something extraordinary, a firestorm of starbirth. When two galaxies collide, the gravitational forces compress the interstellar gas clouds in both galaxies. This compression triggers the collapse of those gas clouds, leading to the formation of new stars. It is a starburst, a period of intense star formation that can produce billions of new stars in a relatively short period of cosmic time. The collision would also likely trigger a burst of supernovae, the explosive deaths of massive stars. These supernovae would seed the galaxy with heavy elements, enriching the interstellar medium and paving the way for future generations of stars and planets. It is destruction and creation all at once. The death of two galaxies and the birth of a new one, a cosmic cycle of death and rebirth that has been playing out across the universe for billions of years. But there is another aspect of the collision that we have not yet discussed. What happens to the supermassive black holes at the centers of both galaxies? At the heart of the Milky Way lies Sagittarius A star, a supermassive black hole with a mass of about 4 million suns. And at the heart of Andromeda lies an even more massive black hole with a mass of about 100 million suns. When the two galaxies merge, their central black holes will also merge. They will spiral toward each other, emitting gravitational waves, ripples in the fabric of space-time as they approach. Eventually, they will coalesce into a single, even more massive black hole. This merger of supermassive black holes would be one of the most energetic events in the universe. The gravitational waves it produces would ripple across the cosmos, distorting space-time itself. And the newly formed black hole would become a fearsome, hyper-energetic, astrophysical monster. But here is the interesting thing. That supermassive black hole, once formed, would prevent nearby gas from cooling down and gathering up to form new stars. And without new stars, you will not get new planets. The merged galaxy, for all its dramatic formation, might actually be less hospitable to life than the galaxies that preceded it. This is the paradox of galactic mergers. They create, but they also destroy. They bring new stars to life, but they also extinguish the conditions that allow stars to form. They are both creative and destructive, all at once. Now, let us return to the question of our solar system. Because despite all this cosmic drama, the fate of our sun and planets might be surprisingly mundane. Galaxies are mostly empty space. As one astronomer put it, if the sun were a ping-pong ball, then Proxima Centauri, the closest star to the sun, would be a pea about 680 miles away. Despite containing more than 1 trillion stars combined, the galaxies are so diffuse that actual star-on-star collisions are incredibly unlikely. None of the 1.3 trillion stars are expected to collide during the Andromeda Milky Way collision. The solar system will in all likelihood be almost unaffected. A galactic collision will not violently throw planets and stars around like billiard balls, but it will change things. The gravitational forces of the merging galaxies will reshape the orbits of stars. Our sun will likely be pushed into a new orbit within the merged galaxy. There is a 50% probability of the solar system being displaced 3 times its current distance from the galactic core, and a 12% chance of ejection into intergalactic space. If the collision occurs, we would end up at the very outer edge of the new Milky galaxy, a lonely outpost in a new cosmic neighborhood. The night sky from a future Earth, if anyone was still there to see it, would be spectacular. The distorted disk of Andromeda would dominate the view, appearing far larger and brighter than anything we see today. But of course, there will be no one there to see it. The sun will have expanded and consumed our planet long before the galaxies make their final approach. The collision of galaxies, whether it happens or not, is a footnote in Earth's story. And yet, there is something profoundly moving about all of this. The fact that we can even have this conversation. The fact that we, a species of upright apes on a tiny planet orbiting an ordinary star in an ordinary galaxy, can look billions of years into the future and ask questions about the fate of the cosmos itself. It is a testament to the power of human curiosity, to our insatiable desire to understand, to our refusal to accept the world as it is, always pushing, always questioning, always reaching for something more. The story of the Milky Way versus Andromeda is, in the end, a story about us, about our place in the universe, about our relationship to the vast, beautiful, terrifying cosmos that surrounds us. We are stardust, contemplating the fate of stars. We are fleeting, yet we reach for eternity. And in that reaching, in that searching, we find meaning. So where does that leave us? What is the final verdict on the Milky Way versus Andromeda collision? The honest answer is that we do not know, and that is okay. The universe is under no obligation to make sense to us. It is under no obligation to follow our predictions or conform to our expectations. The universe is what it is. And our job as scientists, as storytellers, as human beings, is to observe it, to understand it, and to share what we find with others. The 2025 study did not give us a definitive answer. It gave us something perhaps more valuable. It gave us humility. It reminded us that the universe is far more complex and far more surprising than we can imagine. It reminded us that certainty is a luxury we cannot always afford. And it gave us hope. The hope that our galaxy might survive, that the Milky Way, our cosmic home, might continue for billions of years to come, that the future is not written, but is still being written by forces we are only beginning to understand. Even using the latest and most precise observational data available, the future of the local group of several dozen galaxies is uncertain, Sawala said. And that is the beauty of it. The uncertainty, the possibility, the cosmic coin toss. Whether Milkomeda is born or the galaxies drift apart, the story of the Milky Way versus Andromeda is a reminder of something profound. We are part of something vast and ancient and beautiful. We are part of a universe that is constantly changing, constantly evolving, constantly surprising us. And we are lucky enough to be alive at a time when we can ask these questions, when we have the tools and the knowledge to look billions of years into the future and wonder what we might find. The stars are waiting, and the story, dear listeners, is far from over. This has been Night Tales Docs. Thank you for watching, and remember, the universe is still writing its story, and we are privileged to be part of it.